Hello everybody. This video will cover the questions that we had during our discussion section on Monday during our little review competition. So let's go ahead and get started. Get my pen going on here and I'll do red today. Alright, so when we look at this very first question here, number one, we're trying to read this graduated cylinder, right? The thing to pay attention to is not only the numbers in the numbers that you see there, uh, where the meniscus is sitting, right? But also where the increments are as well. Okay? And so when you read the numbers here, this first line here where the 50 is should be 50.0, right? Should be 50.0. Why is it 50.0? Because the next line actually here is the 52.5 line, right? And then the one after that is the 55.0 line, right? And then the one after that, right there, is the 57.5 line, right? So those are the known values of those lines because those lines are present. So we always tell you in lab that you should always read one extra than the known value, right, of the line. And so the one extra of the known value will be adding an extra zero when you report this volume. And so since we're sitting here at 50 right here, you add one extra, that means it's going to be 50.00, right? So again, you've just got to pay attention to both the increments and the numbers that are on the lines, right? The numbers that are on the line. So let's go ahead and look at number 2 now, right? We have 12 here, and we have 13 there. So the lines in between, there are 4 of them here, means that this is going to be 12.2, 12.4, 12.6, and then 12.8, right? And so those are the lines there, which means that these actually are 12.0 and 13.0, right? So again, we have these 3 digits here that are representative of the lines that are present, and we always report the number as being one extra significant figure, right, or one extra digit than what we can read. And so since we can read 3 digits here, one extra we would report as 12.0, right? So there's your extra digit. Okay, so let's look at the next one. The next one's a little bit more complicated because it's going one at a time here, right, like we did a second ago. So we have 31 there and 32 there, which means the line that's right here is going to be 31.25, right? And then the line right here is going to be 31.50, and the line up here, right, is 31.75. Okay, so if we're going to read this, then we're actually at the I'm sorry, I wrote it below it, but that's okay. It's still the same increments right above it on 32, right? We're here at this line right here, which means we're at the line 32.2. And since you can read the line 32.2, you always report one extra digit. So the answer here, 25. There we go. And since you can read the line 32.25, we always report one extra digit. And so 32.250, okay, because it's on those lines. Now, if it were somewhere in between the lines, then it would not be 0, right? If it were slightly above the line where we are at, the meniscus was, then it would be like 25.255, right? With that 5, that extra 5 would be our extra digit. We'll see that in a second. So here on this one, right, we're going in increments of 10 here, right? So here's 20 and 30, and in between we have 4 lines. So again, we're going to be doing 20.2, 20.4, 20.6, and then 20.8, right? So those are the 4 lines right there. I messed up. I'm sorry. I read that wrong. Actually, it's supposed to be 22, right? And then 24, 26, and 28. See, like I said, you got to really pay close attention to what you're reading there, right? Because that's going from 20 to 30. That's not going 20 to 21, right? So you just have to pay attention to what you're reading there. So knowing that these are the lines that you can read, 22, 24, 26, and 28, we always report the one that's one extra digit. So this one here would be 28.0, right? Because our extra digit would be that 0.0 right there, right? So again, you've just got to be careful. I just made that mistake here where I thought that we were going from 20 right here to 21, right? But it's not. It's 20 to 30, which means you're going 22, 24, 26, 28, not 20.2, 20.4, 20.6, 20.8. Just got to make sure you're paying attention to the increments and also the numbers that are labeled there, okay? These are changing by the ones place and not the tenths place like I thought they were originally, so that's why I had to fix that there, right? So just make sure you're paying attention to those numbers. It's very easy to especially when you see a whole bunch of them next to each other, it's very easy to kind of make a mistake and read it wrong, okay? All right, so let's go to the next page. We were doing metric conversions now, right? Or not metric conversions, but dimensional analysis. Most of it is metric, and so most of it is metric. So let's just go ahead and do this. If we have 261 grams, how do we convert that to kilograms? It's pretty simple. We'll do 261. I always start out with whatever the beginning of it is, right? And so that's 261 grams. And then I'll start drawing my fence post. And so remember that when you're doing your fence post or your dimensional analysis, as we call it in college, your goal is to cancel out all the units you don't want and to get to the units that you do want. So if we're going from grams to kilograms, I know that for every 1,000 grams, there's 1 kilogram, right? And so it's as easy as that, because now I can cancel out grams here, and then just multiply 100 or 261 times 1 and then divide it by 1,000. And so the answer to this one would be 0.261 kilograms, right? And so I have, whoops, didn't mean to zoom in there. So I have 3 significant figures right here, right? For my beginning right here, I have 3 significant figures. And at the end here, I have 3 significant figures. So that means that my answer is actually, it is indeed that, 0.261 kilograms. All right, and then 3 days to seconds, right? You can, if there's definitely conversion for days to seconds, like however many seconds there are in a day. But I find it easier so I don't have to memorize it just by going to conversions that I already know. And so I'll start out by saying days here, 3 days, right? And so for every 1 day, I know that there are 24 hours in that day. And then for every 1 hour, I know there are 60 minutes. And then for every 1 minute, right, I know there are 60 seconds. Right? And that way, when I do it this way, because I could have gone straight from days to seconds if I had a conversion factor for that, but I don't have that memorized, so I'm going to do things I do know. And so you do it this way, you don't have to memorize as much stuff because everybody knows that there's 24 hours in a day. 60 minutes in an hour, and 60 seconds in 1 minute, right? So now all I have to do is multiply all the way across 3 times 24 times 60 times 60, right? And then divide all that by 1 because 1 times 1 times 1 is 1. And what I'm going to get as an answer on my calculator is 259,200. And so that's not the correct answer though, right? Because we only have one significant figure here for the 3 days, right? One significant figure. So how do I change this number to the correct answer in significant figures? Well, to get into one significant figure, all you have to do is take this the front right here, right, and round it up to 3 because it's a 5, so you round it up. So now my answer is 300,000. No, sorry, I have an extra 0 there. That extra 0 shouldn't be there. There we go. So now my answer is 300,000 seconds. And so since there's no decimal point there, we know that that 1 3 there is the only significant figure we have there, which matches one significant figure for 1 day, right? Next one, so 9,474 millimeters. Set up my fence post, and so I know that for every 1 centimeters, there are 10 millimeters, right? And so all I have to do now is multiply by 1 and then divide by 10. So that gives me 947.4 centimeters. And then if you look here, we have 4 sig figs, and then we have 4 sig figs here. 4 FS, I don't know what that means. 4 SF, sig figs. So we know that that answer is indeed complete. Okay. Next one, we're going from 7.73 kiloliters. All right, kiloliters. And we wanted to go to that from that to liters. Well, easy conversion because I know that for every 1 kiloliter, right, we have 1,000 liters, right? That's all I have to do now is multiply 0.73 by 1,000, right? And so that gives me 730 liters. And then I'll take a look and see how many sig figs I have. I have 2 sig figs here, and notice I have 2 sig figs here, and so my answer is complete. All right, my answer is complete. So again, I just want to, before I go on, I just want to make sure you understand and you remember that the point of this is when you're doing a conversion like this with dimensional analysis is to cancel out the units that you don't want so that you can get to the units that you do want, right? So going back to number 2 here, I can cancel out days, right? Because days divided by days, and then hours, minutes. So all those get canceled out, leaving me with the unit that I cared about, which is seconds, right? Same thing here with number 3, right? I want to convert from millimeters to centimeters, so I can cancel out millimeters, and I'm left with just centimeters. And the same thing here, we started with kiloliters, but I don't want kiloliters, I want liters. So here I can cancel out kiloliters, and I'm left with liters, right? So if you're doing this dimensional analysis and you don't come up with the right units at the end, you know you did something wrong, right? You know you did something wrong, okay? Let's do a few more of these that we did in class and during discussion. So the next one has some cubes in it. I know that confused some people, right? So we'll start out by saying 0.93 cubic centimeters and set up our fence post again, right? And so I'm trying to get from cubic centimeters to cubic meters, right? And so I know that, for example, that there is 100, right, centimeters cubed for every meter cubed, right? And so the thing that you just have to remember is that when you're doing these, when you have these conversion factors and you have a cube on it, you've also got to cube that as well, right? You also got to cube that as well. And so when you do that, now you don't have to cube the original uh, you don't have to cube the original measurement, right? That's already in the cubic form per se, but the conversion factor does need to be cubed, right? And so all you have to do now is multiply 5.93 times 1 and then divide it by 100 cubed, right? And the answer you should get is 0.00. There's a lot of zeros here. Let me make sure I count them right. 3 zeros and then 2 more zeros and then 593. Well, that answer looks so ugly, right? So what can we do to make it look a little bit better? Make it easier to read. We can change it to scientific notation, and while we're doing that, we can also make sure that it is in the right number of sig figs, right? Because we have 3 sig figs here. Okay, so I'll move my decimal point 1, 2, 3, 4, 5, 6 times, and so what that means then is that my final answer is going to be 5.93. Oh look, 3 sig figs, wonderful, times 10 to the negative 6, right? Because I moved it back 6 times, and then don't forget your units, meters cubed. Okay. Some people got a little bit thrown for a loop when they saw the CG here. CG is just centigram, right? So it's pretty easy to do because all you have to do is say 498.82 centigrams, right? Set up your dimensional analysis or fence post, and then you think to yourself, right? For every 1 centigram, what is the conversion factor? It's 10 milligrams, right? So 10 milligrams equals 1 centigram. It's that easy, right? So now I can cancel out the CGs. I'm left with what I want, which is mg, milligrams. And so now all I have to do is multiply 498.82 times 10, right? And that gets me 4,988.2 milligrams, right? And then we have 5 sig figs up here, and we have 5 sig figs here, so that's our final answer. All right. Oh, I forgot to do something number 5. You don't have to do this, but again, I just wanted to demonstrate to you how you're canceling out the units that you don't want, which in this case here for number 5 is cubic centimeters, right? And it got you to cubic meters, which is what you needed, right? I don't always do the canceling out like that, but if it helps you just to make sure you get to the right units at the end, hey, so be it, right? Do what you need to do. All right, so we have another cubic one here. It's 1 foot cube, or 1 cubic foot, right? So we'll start off with 1 foot cubed, or 1 cubic foot in our dimensional analysis, right? And again, I don't know like the exact I don't have it memorized what the exact conversion is between feet and meters, but I do know some stuff in between. For example, I could do for every 1 foot cubed or cubic foot, right? I know there are 12 inches cubed, right? And I'm putting the cubes on both the numbers and the units, so you remember to cube those numbers of the conversion factor, right? Okay, well, you're saying to me now, well, that doesn't help because you're trying to get to meters. How do you get to meters from inches? Well, that's a conversion I do remember, right? And it'll be on your list too, right? Because for every 1 inch cube or 1 cubic inch, for every 1 cubic inch, you have 2.54 cubic centimeters. Uh-oh, look at that. We've converted from imperial to American now, right? Because we're in centimeters. That's great because now all I have to do is figure out how many centimeters are in a meter, and then I'm at the meters. It's great. So that's pretty easy because we know that there are 100 cubic centimeters in a cubic meter, in a single cubic meter. And look at that. That's what I was looking for right there. Cubic meters. And now I have cubic meters, right? So I'll go through and this is a long one, so I'll go through and cancel out the units so that I can keep myself clear. My feet cancel out from there to there. My inches cubed cancel out from there to there. Centimeters cubed cancels out from there to there, and then I'm left with what? Cubic meters, which is the answer, which is the unit I'm looking for, right? So it's easy as this. I multiply 1 times 12 times 2.54, right? And then after I do that, I divide by 100 cubed, right? So don't forget to do the cubing, right? So multiply 12 cubed times 2.54 cubed, right? Don't even have to worry about the 1 because you multiply 1 by anything, it stays the same. So save yourself some time and just do the 12 cubed times the 2.54 cubed, and then divide that by 100 cubed. And that will give you the answer 0.028316847. So yeah, that's definitely not a number that would be acceptable, right, as an answer, because you only have one significant figure here. And there's a lot of significant figures there if you answered it the way that it's given you, right? So how do I make this one significant figure? Well, the easiest way to do this is turn this into scientific notation. So I'll move the decimal point over once, twice, right? So that leaves me with the decimal point behind the 2. But I can't say 2.8, right? Because if I do 2.8, right, that has 2 sig figs. So I have to do something else, right? And so what I'll do is, since this 2 is a before an 8 here, right, it gets rounded up. And so that's why I'll do 3 for 2 getting rounded up to 3 because of the 8 times 10 to the however many movements I made. I think it was 2, right? So that's to the negative 2 meters cubed, right? So just remember your sig figs there, okay? Again, this is another one of those 1 year to 1 minute to minutes thing. I mean, if you know how many minutes there are in a year, hey, good for you, but I don't. So I'm going to do it my way. That's the easy way that I remember things. I have 1 year. For every 1 year, there is, for every 1 year, there's 365 days. And then for every 1 day, there is 24 hours. For every 1 hour, there is 60 minutes. Beautiful, right? Beautiful. And so I started with year, and I want to end it with minutes, and so I'll cancel out the years, cancel out the days, cancel out the hours, and look what I'm left with, minutes. Beautiful, right? So just save yourself some time. Don't type in the ones because you multiply them, they just come out the same anyway. So all you have to do here is multiply 365 times 24 times 60, right? And then under there is all 1, so divide by 1 if you want to, but save yourself some time. And then you will get the answer 5 in the calculator. It'll be 525, and I think my head's blocking it right now, so I'm going to go right up here. Okay. So for this one, it's going to be 525,600 minutes. Oops, I'm on the wrong page. Sorry about that. So over here, for number 8, 525,600 minutes, right? But how many sig figs do we have there? Well, we need to have 1 sig fig. There's 4 there, right? So we need to change that to the correct number of sig figs. And so here, again, you don't even have to do scientific notation here. I would just look at the very first numbers there, and that's a 2 right there behind that 5. So it stays the same. It doesn't round up. So your correct answer would be 500,000 minutes. You round down to 500,000 minutes to get you to the correct number of sig figs. All right, so that would be the answer to that one. And then I think this may be the last one we did during the... no, I don't think it is actually. Maybe it's the second to last one. Yeah, so this is the second last slide. Let's do one. This one's really easy. It's only one step, right? Because we have 175 pounds, right? And for some reason my pen is writing thicker now. It's freaking me out. So, oh, there we go. So 175 pounds. Set up a fence post right there. And so I know that, and this will be in your notes, by the way, or your chart. There is 2.2 pounds, right, for every 1 kilogram. Right, so it's just one step. All you have to do is divide 175 by 2.2. You'll get a long thing here. It's 79.5454. A lot of 5 4s. And then 5 5. You only have 3 sig figs here. So how do we make the 3 sig figs? You just count your 3 sig figs here. So 79 point. That's 2 sig figs, and now we have to add the 5. But since the number after the 5 is a 4, it stays a 5. It does not get rounded up, and so that's not your number. Your answer, 79.5 kilograms. Right? Pretty easy. Next one, another pretty easy one. 4.65 kilometers. Right? And so I know that for every 1 kilometer, right, because it's in your chart, there's 1,000 meters. And look at that, we're looking for meters, right? So it's easy as just multiplying by 1,000 this time around, right? Multiplying by 1,000 because the km's cancel out. Just like here in number 9, the pounds cancel out, right? So, but here, the km's cancel out. And so the kilometers cancel out, leaving you with meters. And so the answer there would be 4.65 times 1,000, which gives you 40. That's not 40, but 4,650, right? And we have 3 sig figs right here, which means that we need to make sure we have 3 sig figs here. This is 3 sig figs here, so that's good. We don't have to do anything different. And then all we have to do now is add the unit at the end, okay? And then next one, right? This one's pretty. So this one's both easy, but if you're not really used to it, then it's kind of not easy, right? But if you don't know how to do it easily, then we can always let's just go through the steps, right? Because you're still doing the same thing as you did before, where you start out with a unit and you're trying to get to another unit, so you're gonna try to get things canceled out, right? So when you have a measurement that is like 2-dimensional, right? It has both a weight or mass and liters, right? The way you would write that in your dimensional analysis is you would write that 22.4 rather, not 2.2 but 22.4, right? And then kg, right? But then the per liter part goes below it. And remember what I said in class, if there's no number there, that means that it's just the 1. So you can just put 1 liter there, right? So what it's saying there is whatever this thing is, it has a density of 22.4 kilograms per liter, right? And so now it's wanting you to convert it to kilograms per mil, right? So that's pretty easy because the kg actually stays the same, right? You don't have to do anything with the mass. All you have to do is convert the liters, right? So you started here with liters down here, right? We want to go to milliliters, and so we know that for every 1 liter, there's 1,000 milliliters. So cancel out your L's here. It leaves you with an ml here. Beautiful, right? And so all you have to do now is take 22.4 and divide it by 1,000, right? And that should get you the number 0.0224, right? But is that the correct number of significant figures? No, because I have 4 sig figs here, but here I have 3. So I've got 3 sig figs. So I will drop that 4 right there and not round it up because it's a 4 and not a 5 above. And so my answer is going to be 0.022. And now I have 3 sig figs, right? And this does, just don't forget your units, kilograms per mil. Right? Don't forget your units, kilograms per mil. And then number 12 here, another one of those that has a per something, like a multi-dimensional unit here, right, or measurement. So we'll do it the same way we did the last one. 0.74, and I'm going to run into my head again, so I'll start writing it over here on the side here, but we have 0.74 kilocals, and then so again, in front of this minute right here, if there's not a number, it's a 1, so you can just put 1 minute, right? And it wants you to go from kilocalories to calories, and then from minutes to seconds. So that's a two-step process, right? Because you have to convert the calories first, and then convert the kilocalories to calories first, and then convert the minutes to seconds. It doesn't matter which one you do first, but you still have to do both, right? So how do I do that? Well, I'll start out with the calories first. I know that for every 1 calorie, for every 1 kilocalorie, right, I have 1,000. Oops, sorry about that. I don't know what happened there, but 1,000 calories, right? 1,000 calories. And then that's the convert. So that was the conversion for kilocalories to calories. And then I have 1 minute. I know that for every 1 minute, there's 60 seconds. Right? So if you take a look at what we have now, right? I have now, if I start canceling things out, I can cancel out the kilocalories, right? And then I can cancel out the minutes. And then what am I left with? I'm left with cal, right, on top, and seconds on the bottom, which is exactly what this is. Cal on top, seconds on the bottom. Perfect. So all I have to do now is multiply the 0.74 times the 1,000, right? And then divide that by 60, and I'll get my answer. And so the answer to this one is 12.3 from the calculator, 3, and that's a whole bunch of 3s, right? But remember, you only have 2 sig figs here, which means that this answer is actually going to just be 12. 12 cals per second. Right? 12 calories per second. Okay? Ignore that little mark I made there. Okay? Actually, I'll just erase it so that doesn't confuse anybody. And of course, it's just 12 because 3 is less than 5, right? And so if it's less than 5, you're going to, keep it the same number and not round it up. Okay, so the last page we're doing is going to be this page right here. This is the last one we covered in class that day. Oh, I just realized something. This is probably blocking my head over here on the right side, so I'll rewrite it over here. Being blocked by my head. So the calculator number I got was 12.333. A whole bunch of 3s, right? But that's not the right number of sig figs, so we'll just drop all the 3s, right? And now we have 12, and that's 2 sig figs, just like the original number was, cals per second. All right, cals per second, okay? And it stays 12. It doesn't go up to 13 because 3 is less than 5. All right, so let's do these last ones now, and then this is this particular series of questions is more. There are more of these questions, but we'll cover those in our next discussion. So I'm not going to do those in this video. Okay. All right. So we have another multi-dimensional one here, and it also has some cubes. I mean, not cubes, but squares in it. So don't fret. Treat it like you would treat anything else. Right. So we'll start with 142 grams. Remember, if there's not a number between there, right there, that means it's a 1. So that's 1 centimeter squared, right? And so it wants me to go to milligrams per, I don't know why I just made that red line, but it wants me to go from milligrams to milligrams, it wants me to go to grams. It wants me to go from grams per centimeters squared to millimeters squared. Well, say that 5 times fast. Anyway, so I have my beginning numbers over here already, right? So we can take this one at a time. I'm going to say, I'll start with the bottom this time, right? I know for every 1 centimeter squared, there are 10 centimeters squared, right? 10 centimeters squares. It's weird, right? And then, so that's the conversion from the centimeter squared to the millimeter squared. And then for the grams, I need to go to milligrams. And so I know that for every gram squared, not squared, sorry, just grams, for every gram, those little red lines are really bothering me now. Let me erase them. There we go. For every gram, there are 1,000 milligrams. Right? And so all I have to do now is cancel stuff and do math, right? So I'll cancel out the centimeter squared, right? Oh, I messed that up there. That should actually say millimeters. Let me fix that. We're writing too fast. There we go. So, like I said, I'll cancel out the centimeter squared, leaving me with millimeters. This is what I want right there. And then grams cancel out, leaving me with milligrams, which is what I want right there, right? And so it's easy as just multiplying 1.42 times 1,000 divided by 10 squared. I think the important thing just to remember is that if you have a 10 squared, don't forget to square it before you put it in the calculation. And so the 4.2 is going to be your answer here, milligrams per millimeter squared, right? I have 3 sig figs here, and I have 3 sig figs here, and so that means that I have the right number of sig figs already. Okay. Here's another multidimensional one here, where we're going from meters per second to miles per second, and so this is pretty simple too, because seconds actually stays the same. You don't even have to change. You don't have to convert seconds at all. So it's going to be 1,095 meters, right? And then per 1 second, right? And then this should be on your conversion list, right? But for every meter, for every 1 mile, there are 1,609.34 meters, right? 34 meters. And so we don't have to do anything with the seconds because it's still seconds at the end here, right? So all we have to do is divide 10,095 meters by 1,609.34 meters to get to our miles, right? And that gets us to, so that's canceling out the meters, and that gets us to the answer of 6.2728 miles per second, right? Miles per second. And we have 5 sig figs there, we have 5 sig figs there, so good, we're done. So if you remember, during the discussion, during the competition, I was saying if you know any physics, then this is actually a really easy question, right? Because 9.8 meters per second squared, right there, 9.8 meters per second squared is actually gravity. That's what gravity's acceleration is, right? So whenever you talk about Newton's laws, like F equals mg, that the G stands for gravity. That G right there, right, that is this number right here. So that's the acceleration of something falling towards the Earth, right? And so I said this was easy because in physics class, we always use metric, right, which is 9.8 meters per second squared, right, or 9.81 meters per second squared. But in calculus class, when we're doing these, they always do it in imperial, right, when you're in calculus. And so you know that from calculus, then that instead of using 9.8 meters per second squared, it actually converts to 32 feet per second squared. Right? So that's the conversion between those two. So in physics class, we use 9.8 meters per second squared, but in calculus class, we use 32 feet per second squared. Sorry, I don't know why I put an M there. That should be an S. There we go. Squared, right? So it's just interesting that in math we use the imperial, and then in physics we use the metric, right? But anyway, how do I know this is right? Like, I mean, I had both classes, so I've heard both numbers in both classes, right? So it has to be right. But how can we prove that it's right? Well, let's just do the calculation, right? And so uh, we'll start out by going 9.81, right? And again, we have meters at the top divided by seconds squared at the bottom, right? Remember, nothing there means it's a 1, right? And then it's an easy one too. This is easy because both of these are seconds squared, so you don't even have to do anything with those, right? So you're just going to feet. And so for every 1 meter, there are the 3.28084 feet, right, in 1 meter. And so if you calculate that out, you end up with, all you have to do is, the meters cancel here, right, leaving you with feet per second, which is what you wanted, feet per second. That's great. So all you have to do is multiply them out, and 9.81 times 3.28084, and you get 32.9 feet per second. It's weird, right? And 3 sig figs, and then 3 sig figs, right? You can see how it's 32 there, 32 there, right? I didn't finish writing it out, but you know. All right, and so the last one, and I know this one's definitely going to get covered by my head, my headshot there. So we'll move it over here. We're going from 80 we're going from 8.41 grams per mil, which is another density, to kilograms per liter, which is a density as well, right? So there's something special about this one here, and you'll see it when it happens, right? I'll go 8.41 grams all over 1 mil, right? Okay, and then I don't know what's happening here. Okay, per mil, and then I got a little too close to the controls there, so I started messing up. And then so after you do that, right? We are going. You can choose which one you want to go to. You can either convert the volume first, or can convert the mass first. Well, I'll convert the volume first. So I know that for every 1,000 mils, there is 1 liter, which is good because it wants me to go to liters right there, right, at the bottom. And then for, now that we've converted to liters already, we'll do the grams, the mass. I know that for every 1 kilogram, I have 1,000 grams, right? And that's it. So my grams cancel out, my mils cancel out, and so that leaves me with kilograms at the top and liters at the bottom, and so that's the unit I'm looking for right there. So now I just multiply 8.14 times 1,000, and then divide it by 1,000, and so the answer I will get is going to be 8.41, right? And we have 3 significant figures there, and we have 3 significant figures here. That's good. Kilograms per liter. Huh. What's that special thing that I mentioned at the very beginning of this particular problem? It's the same answer. Look, 8.41, 8.41. That's crazy. What does that mean? That means that 1 milligram per mil is actually the same as 1 kilogram per liter, right? So they're a 1-to-1, right? 1 kilogram per mil is equal to 1 kilogram per liter, right? So sometimes you get lucky that way, where it's the same thing, right? You end up with the same number again. All right, so that's the end of those questions. We'll finish the rest of these questions later in discussion on Monday, and I'll post a video for those as well. And then I'll also post I will also post these questions in paper form on Canvas for you to practice and go through and do these and make sure you get the hang of how to do these particular dimensional analysis questions. If you have anything else, let me know, and I'll see you in the next video or in class.